Welcome to the deep dive. This is where we really get into the weeds, sorting through research papers, articles, you name it, to bring you the insights that matter. And today we're diving into something truly fascinating, the connection between how we learn, how we feel, and how technology might just change everything. We're focusing on the work of Dr. Barry Kort, particularly his research from the MIT Media Lab on effective computing, and this really interesting idea he comes learning companions. Our mission for this deep dive, basically to unpack Kort's main ideas. We want to explore how emotions aren't just, a side effect of learning, but actually drive the whole process. Then we'll get into this pretty revolutionary concept, an AI learning companion. What is it? How is it different? And finally, we'll think about what this all means for education today, for how you listening might learn best, and, well, for the future of humans and AI working together to learn. We're pulling directly from Kort's papers and presentations here, so we're going right to the source to understand what real learning looks like and how tech might help us get better at it. Okay, so let's unpack this first bit. Dr. Kort and his team, they start by pointing out something pretty fundamental that's maybe wrong with how we usually teach, especially in subjects like science, math, engineering, technology, the SM-IT fields, as he calls them. When you think back to school, maybe your own experience, what was the main focus? A lot of the time, it was memorizing things, right? Facts, formulas, steps to solve a problem.
It's exactly.
We were basically trained, in Kort's view, to be rule-based reasoners. We learned the what, what's the formula for this? What are the steps for that?
Like, follow the recipe.
Yeah. And on the surface, that kind of makes sense. You do need the basics. But the big question Kort raises is what happens when you hit a problem that doesn't fit the rules? Something genuinely new.
And that's where Kort's insight is really, really fascinating. He and his collaborators argue that the people who really innovate, the scientists, the engineers, the tech pioneers pushing boundaries,
Hmm.
they aren't primarily rule-based reasoners. Not really.
Okay. So what are they, then?
They're what Kort calls model-based reasoners. And that means they could do much deeper things like recursion, breaking problems down or applying a process to itself, plus diagnostic reasoning, cognitive assessment, appraisal. It's a whole different toolkit.
So it's not just knowing what to do.
Exactly. It's understanding how to learn, how to figure things out when there is no rule book, how to tackle completely unique problems. They could take complex things apart, figure out what went wrong, and then, build new solutions. It's that difference between knowing the answer and knowing how to find an answer when nobody knows it yet.
And that feels like exactly where the standard classroom often falls short, doesn't it?
Absolutely.
Because when teachers present stuff, it's almost always perfect, polished, no mistakes.
Yeah, like those cooking shows where everything's pre-chopped and magically clean.
Right. The final dish looks amazing, but you miss the whole messy process.
Exactly. You don't see the trial and error, the moments where the chef was totally confused or had to fix something that went wrong.
Or recovering from frustration, figuring out why it went wrong.
Yeah.
And then, crucially, starting over with, fresh energy. All that vital, messy stuff, it's usually hidden.
And think about how that impacts you as a learner. Maybe you're in a tough class, math or physics or something. You're wrestling with it, and it's just not clicking right away. Or your first try doesn't work.
Yeah, happens all the time.
In that traditional polished system where mistakes feel like failure.
Yeah.
Well, you might start thinking negative things about yourself.
Like, I'm just not good at this. Or worse.
Or I'm stupid, yeah. Because the answer wasn't obvious. But the critical lesson that's missing, Kort argues, is that those feelings, the confusion, the frustration, they aren't signs you're failing.
There's something else?
They're normal. They're essential. They're actually valuable parts of learning. Think of them like signals.
Signals?
Yeah, signposts. That feeling of frustration, it's not telling you to stop. It's telling you your current approach isn't working, your mental model is incomplete. It's a signal to adapt, try something new. It's like an internal nudge.
Okay, so if the old way falls short in building this learning intelligence, what's the alternative Kort proposes? Is it a total revolution in teaching?
It's definitely a fundamental shift. He pushes for what he calls a model-based reasoning pedagogy.
Okay.
So it's evolutionary, maybe, but profound. It's not just about delivering content anymore. It's about building the skills of learning intelligence.
Like teaching resilience.
Exactly. Teaching students how to handle setbacks, how to navigate that frustration, and crucially, how to tackle problems they've genuinely never seen before. And the core focus of their research, it's not just about, does being happy help you learn more? That's been studied.
Right.
Their focus is on building a whole theory of effect, the emotional side, specifically in these SMET learning contexts. and then building tools based on that theory. Tools to help students learn how to learn, not just what to learn. As they put it, they pry for a novel model by which to conceptualize the impact of emotions upon learning. It's really about understanding the mechanics of it.
That's a big shift. So, affect.
Mhm.
What exactly does that cover? It sounds broader than just happy or sad.
Oh, much broader. Affect here means the whole spectrum. All the emotional states, the feelings you have while you're learning. It's nuanced. Well, think about axes or continuums.
Right.
You've got anxiety, confidence. You might feel worry, then discomfort, maybe move toward comfort, hope, and finally confidence. It's a journey.
Okay.
Or boredom, fascination. That goes from ennui, indifference, all the way to interest, curiosity, intrigue,
Right.
and a really key one, frustration, euphoria. You might start with puzzlement, then confusion, hopefully leading to insight, enlightenment, maybe even that epiphany moment. The point is, learning involves navigating all these emotional landscapes, and they rarely happen one at a time.
Ah, so you feel multiple things at once.
Often, yeah. Learning activities can trigger feelings on different axes simultaneously. Kort calls it an emotional tug of war.
I like that.
You get that mix of the bitter with the sweet.
Mhm.
Like, you might feel anxious about a hard problem, but also intensely curious about solving it. That complex mix isn't just there, it's actually driving the learning forward.
That emotional tug of war, it really resonates. It reminds me of, say, a coach training a marathon runner.
How so?
Well, a good coach doesn't just teach running form or pacing, right? They teach the runner to understand their body's signals.
Ah, I see where you're going.
Yeah, the sharp pain, the fatigue, those weird bursts of energy, maybe a twinge in the knee.
Mm-hmm.
The coach helps them interpret those signals, respond strategically, not just to finish, but to improve, become more resilient.
Right. Pain isn't just bad, it's information.
Exactly. It might mean adjust your stride, reevaluate, not just quit. It's moving from knowing what to do to understanding how to adapt emotionally and physically while you're doing it. That feels like the shift Kort's talking about.
Okay, so with that powerful understanding of emotions' role, the obvious next step is how do we actually use this? How do we put this deep understanding of emotional dynamics into practice? And this, I think, is where Kort and his team introduce something really, really interesting. The learning companion.
Yes, the learning companion. The vision is for a software-based interactive application.
And its core job is to recognize the learner's state, both affective, so how they're feeling, and cognitive, what they're thinking, and then respond intelligently.
Intelligently how?
Well, it doesn't just dump information. It can dynamically adjust things, like the pace, the difficulty level, how subtle the hints are, maybe the overall complexity of the task.
So it adapts in real time.
That's the goal, like having a really perceptive, knowledgeable guide sitting right there with you, responding to how you're actually doing moment by moment.
Now that sounds a bit like some things we've seen before, maybe, like intelligent tutoring systems, IT. How is this learning companion different?
Ah, that's a really crucial distinction, and it's central to Kort's whole vision. Traditional ITs, they act like tutors, right?
Yeah, they know the subject, they give you answers, correct mistakes.
Exactly. They know the answers.
Hmm.
The learning companion is fundamentally not a tutor in that sense.
It's not?
No. It's explicitly designed to be, quote, a player on the side of the student, a collaborator.
A collaborator.
Right. Its main purpose isn't teaching the subject matter directly.
Yeah.
It's facilitating the child's own learning efforts. And maybe even more importantly, helping them learn how to learn better.
So less about fixing my calculus mistake, more about helping me not give up on calculus.
Precisely.
Yeah.
It's about supporting perseverance, especially when that frustration hits and the urge to quit is strong. It's trying to build that resilience, that metacognitive awareness, helping students understand their own learning process, emotions, and all.
Okay, let me try an analogy. Imagine you're learning, I don't know, a new programming language. It's tough. Instead of a system that just spits out the correct code when you're stuck, imagine having this wise, patient friend beside you.
Okay.
They don't give you the code, but they notice when you're getting tangled up or about to throw your hands up or maybe just zoning out.
Right. They sense the state shift.
Yeah. And they gently nudge you. Maybe they rephrase the confusing part, suggest a quick break, or prompt you to look at it differently. But they don't just solve it for you. It's enablement, not instruction.
That's a great way to put it. Subtle, empathetic enablement. That's the core idea.
So why is that distinction, companion versus tutor, so critical? What was wrong with the old ITICE approach that this learning companion tries to fix?
Well, those traditional eye tests, despite some early promise, they had some pretty big limitations in practice.
Like what?
For one, they were often handcrafted monolithic things, very expensive and time-consuming to build. You almost had to reinvent the wheel for every new subject.
Ah, not very scalable.
Not at all. And they were heavily concentrated on the domain knowledge, meaning their internal logic was often tied specifically to, say, LISP programming or algebra.
Okay.
And while some showed good results in labs like that LISP tutor, reducing time and boosting scores, which is impressive,
Yeah.
Kort points out they often were not designed with significant user input. They didn't really address the practical issues teachers faced using them. They felt more like fancy CD-ROM encyclopedias with some teaching logic bolted on.
So good at delivering information, but maybe missing the human learning process.
Exactly. They often missed that crucial human element, the emotional journey, the learning how to learn part.
And that's where the learning companion comes in, designed specifically to fill that gap.
Precisely. Its design is fundamentally different. It's conceived as a separate module
Modular. Why is that important?
because it means it can be used on its own or plugged into an existing ITS or really any educational software. It's flexible.
Ah, so it doesn't have to be the whole system.
Right. And crucially, its expertise isn't subject dependent. It doesn't need to know calculus or Shakespeare.
So what is its expertise?
Its focus is entirely on those metacognitive and affective tasks. It's asking things like, is the learning going okay or is it off track? Is the learner hitting a wall, getting frustrated? Do they need a different pace or some feedback?
So it's universal, applicable across different subjects.
Exactly.
Yeah.
Huge flexibility. Its AI goals are ambitious.
Mm.
Observe and really understand what's happening when a learner gets stuck, off goal, to help them get back on track. Pay close attention to their emotional state and craft smart, appropriate responses. Dynamically tweak the learning environment, simplify things when frustration peaks, maybe add challenge if boredom sets in, and, critically, understand how to foster those positive emotional states to create genuine, teachable moments, those breakthroughs.
Okay, you mentioned earlier this deep dive would be a roller coaster ride into the calculus of emotions and learning,
Right.
which sounds intense, especially the calculus part. For those of us whose calculus is rusty or non-existent, what's the core idea? How does math help here?
It's a bold phrase, isn't it? But it's about fundamentally reframing how we see learning itself. Kort sees learning as acquiring knowledge concepts, mental models, theories, beliefs, whatever. But, and this is key, it's absolutely not a smooth, steady climb, not a straight line on a graph.
Okay, so not linear.
Definitely not. He says it's non-monotonic, which basically means we learn in fits and starts.
Fits and starts.
Yeah. We pick up these little units of knowledge, he calls them knolls, and we weave them together into this complex fabric of knowledge.
Okay.
But this process isn't neat or error-free. Not at all. We constantly pick up misconceptions, wrong ideas, flawed beliefs. We struggle with them.
So it's not just about adding new stuff, it's also about getting rid of bad stuff. That sounds tricky.
It is. And that's crucial to the non-monotonic idea. Sometimes we have to actively unlearn things, discard ideas that turn out to be, as he puts it, baloney.
Baloney.
So our total knowledge can actually go down sometimes before
Yeah.
it goes back up. The learning curve looks less like a smooth hill and more like, well, a rugged mountain range.
With peaks and valleys.
Exactly. Gentle slopes where things feel easy and then precipitous cliffs where you just hit a wall. We all want those eureka moments, right?
Oh, yeah.
But we dread those belief-shattering passages where reality forces us to admit our cherished bright ideas are so much rubbish. Yeah. So that learning roller coaster involves a huge range of emotions. Curiosity, fascination, surprise, anxiety, confusion, bewilderment, frustration, anguish, chagrin, despair, hope, perplexity, elation, satisfaction, confidence. The list goes on, just naming them all as a challenge.
Wow, that is a lot of emotions. And it still feels like a massive challenge for an AI to track all that. Psychology usually talks about fewer basic emotions, right? How does Kort simplify this for an AI?
Right. Just listing dozens of emotions isn't practical for an AI. Kort's approach focuses on identifying specific emotion axes, those continuums we talked about that are most relevant to learning. The key isn't just to put a label on the emotion, but to understand its intensity and, importantly, its direction of change while learning.
Direction of change.
Yeah. Think about that frustration-euphoria axis. A learner might go from puzzlement to confusion. If they get stuck, maybe deeper into frustration. But if they make progress, they might move towards insight or enlightenment. The critical thing for the learning companion is to detect movement along these axes. Like, is the learner shifting from productive confusion into debilitating frustration? That shift is a vital signal.
Ah, so it's the change that matters most.
Often, yes. If the system can spot that critical shift, even at a low level, that's often enough to trigger an intelligent intervention. It's about recognizing the pattern, the trend, not necessarily pinpointing every fleeting feeling with perfect accuracy.
Okay, that makes more sense. So we have emotions mapped on these axes. Now, the calculus bit. You mentioned Kort uses this analogy between ordinary motion, a car driving, and a learning journey. Can you break that down? How do those connect?
Absolutely. It's actually quite elegant. Think about describing a car's trip. We use time, distance, velocity, speed in a direction, and acceleration, change in velocity.
Right, standard physics.
Yeah. And in calculus, they're linked mathematically. Velocity is the rate distance changes over time. Acceleration is the rate velocity changes over time.
Okay.
Newton even talked about jerk, the rate acceleration changes. And later, folks at MIT added jounce, the rate jerk changes, think jump and bounce.
Okay, physics recap complete. How does this map to learning?
Here's Kort's calculus of emotions and learning. Time is straightforward. Time and motion equals time and learning. Journeys take time.
Got it.
Distance traveled by the car is like knowledge gained. The further you learn, the more distance you've covered intellectually.
Makes sense.
Velocity, how fast you cover distance, is like learning, the rate you acquire knowledge. Learning quickly means high learning velocity.
It's learning.
Now, the rate velocity changes. This is analogous to emotions.
Okay, explain that.
Emotions are the rate of change of your learning speed. If you're hitting insights, learning rapidly, positive acceleration, you probably feel positive emotions like fascination, elation. If you're slowing down, getting stuck, negative acceleration or deceleration, you likely feel negative emotions like confusion, frustration.
So emotions reflect how fast my learning is changing.
Interesting.
Then jerk, change in acceleration, becomes shock in learning. Those sudden, jarring emotional shifts. Like realizing a core belief is totally wrong. A jolt.
Right, that belief-shattering moment.
And finally, jounce, change and jerk, is like resilience, your ability to bounce back from that shock, regain your footing, and keep going.
Wow.
It provides a surprisingly scientific way to look at our own learning, making the whole emotional dynamic feel much more concrete, maybe even measurable in theory.
That really is a clever framework. So when you're driving later, you can notice your car's time, distance, velocity, acceleration.
And then tomorrow, when you're learning something, you can think about the parallels. Time, knowledge, learning as velocity, and emotions as acceleration. It helps frame how you feel as part of the process of learning, not separate from it.
Exactly. It integrates them.
Okay, so what does this actually let us do? How does this motion analogy help visualize the learning process, that emotional journey?
What leads directly to a really powerful tool in Kort's framework, the phase plane diagram.
Phase plane diagram. Okay.
Imagine a graph. On the horizontal axis, the x-axis, you plot emotions, which we just said are like acceleration. On the vertical axis, the axis, you plot learning, which is like velocity.
Okay, emotions versus learning speed.
Right. This creates 4 quadrants, and each quadrant represents a distinct phase in the learning cycle. The idea is that a successful learner needs to continuously orbit the loop, moving through all 4, and the learning companion is designed to help keep you moving around that loop.
All right, let's walk through these quadrants, maybe with an example. Say someone learning, recursion in programming. That's often tricky.
Perfect example.
All right.
So, quadrant I, upper
Yeah.
right, positive affect, constructive learning. This is the yay zone. High curiosity, fascination. Our student is coding their first simple recursive function. It works. They're building models, making predictions. Learning rate is increasing. Pure joy of discovery learning.
Feels good, learning fast. Got it.
Quadrant 2, upper left. Negative affect, constructive learning. Now it gets interesting. Maybe they try a slightly harder problem, it doesn't work. An infinite loop, maybe they feel confusion, perplexity. Learning might slow down as they diagnose the problem. They realize their first idea was flawed. This is Kort's now we are really confused phase. Still learning, but emotions turn negative, thoughtful.
Okay. Confusion, but still trying.
Quadrant 3, lower left. Negative affect, deconstructive unlearning. This is often the toughest. Deep frustration, maybe chagrin, feeling dispirited. Our student realizes their fundamental understanding was wrong. They had to discard that flawed mental model, baloney. Kort calls this the dark tea time of the soul. You're tearing down bad ideas. This is where many people give up.
Yeah, the I quit zone, very negative. Learning feels stalled or even reversing.
Quadrant 4, lower right. Positive affect, deconstructive learning recovery.
Yeah.
But then hope. After ditching the bad idea, they feel renewed determination. maybe satisfaction from figuring out why it was wrong. They're ready for fresh research, a new approach. Welcome to Quadrant 4, Kort says. Einstein's quote fits here. If we knew what we were doing, we wouldn't call it research. You're rebuilding, feeling positive again.
So the goal isn't just to stay in quadrant 1, the happy place. You actually need to go through the confusion and frustration.
Absolutely, that's the core insight. You ideally cycle through all four. Those negative emotions in 2 and 2s aren't bad. They're necessary signals. They tell you something needs rethinking, deconstructing.
Wow.
The goal of the learning companion and good learning practice is to keep the learner orbiting the loop, helping them push through 2 and 3 and into 4 and back to I, not get stuck and give up. Without navigating those negative states, deep learning just doesn't happen.
And you mentioned this becomes a helix in 3D.
Right. If you add a third axis perpendicular to the phase plane, representing cumulative knowledge, then each loop around the quadrants also moves you up that axis. It becomes the Excelsior spiral, always climbing the tree of knowledge. Each orbit gives a net gain in understanding. So embracing and navigating the negative emotions is actually what fuels the upward climb.
That's a powerful image. So how would an AI learning companion actually use this model? How does it help a learner based on this quadrant stuff?
That's where the engineering comes in. The AI could use these models, the phase plane, the spiral, to monitor the learner's progress.
Like diagnosing where they are.
Exactly. Is the learner stuck spinning in quadrant 3, showing signs of ongoing frustration? The AI could use that diagnosis to decide how to intervene.
And the interventions usually happen in...
Typically most needed in quadrants 3 and 4, the recovery phases. The AI might offer a hint, some encouragement, maybe an observation to help reframe the problem.
Or change the task.
Yeah, maybe suggest a break, offer a simpler version, or even switch topics for a bit to let the learner regain some positive feeling before tackling the hard stuff again. The aim is always to keep them moving optimally along that spiral, not letting them get trapped in negative states. And a key side benefit is helping learners develop metacognition awareness of their own emotional states and how they relate to their learning.
This is incredibly sophisticated, but the big question remains, how does the computer know? How does it sense, okay, this person is moving from quadrant 2 confusion into quadrant 3 frustration? We're not usually telling it.
That is the absolute core challenge, isn't it? And it's a huge focus of Kort's research in effective computing. They've looked at several ways to try and get a handle on these fleeting emotional states.
What are the options?
Well, historically, you could use questionnaires. Easy to do, good for general things like motivation, the ARCS model, attention, relevance, confidence, satisfaction. But they're static. They don't catch the rapid changes during learning. And people might not be honest, right? They might hide frustration if they think it makes them look bad. Self-report bias is a real issue.
Okay, so questionnaires are limited. What else?
You could look at help-based interactions. Does the student ask for help? Does the system prompt them about how they're feeling?
Seems reasonable.
But again, limitations. Not everyone realizes they need help, especially younger learners or those with weaker metacognitive skills. And some are just reluctant to ask that stigma of being thought stupid. It ties back to not seeing confusion as okay.
Right. So asking for help isn't a reliable indicator for everyone.
Exactly. Then there's self-report via buttons or sliders. Click the I'm confused button or drag a happy sad slider.
I've seen those.
Easy to add, but probably less reliable for diagnosing emotion in flight. When you're deep in a task, are you really accurately identifying and reporting your nuanced feelings? Plus, the act of reporting itself pulls you out of the flow.
Yeah. So all these have downsides. What's the most promising direction then for the AI to actually read us dynamically, objectively?
This is where the really cutting-edge stuff comes in, sentiment modulation.
Instant modulation.
Okay. Kort describes this field as being in its infancy, but it offers potentially the most dynamic and objective approach.
How does it work?
The core idea is that your emotional state subtly changes lots of physical things simultaneously, things a computer could potentially sense.
Like what?
Muscle tension may be clenching your jaw, tensing shoulders, facial expressions, tiny movements, a furrowed brow, a slight smile, how your eyes move, how your fingers tap or move the mouse. Skin responses, electrodermal activity, related to sweat, which changes with arousal, even your voice pitch, pace, volume.
Wow, a whole constellation of signals.
Exactly. The AI's job is to sense a pattern across these multiple signals and correlate it with likely effective states in real time.
Has there been actual progress on this? Or is it just theory?
Oh, there's real progress, though it's definitely still hard, especially with natural, unposed emotions. Rosalind Picard's group at MIT, where Kort works, has done amazing things. They developed expression glasses that can tell the difference between expressions linked to interest versus those linked to confusion.
Really?
Yeah. And physiological monitors sensing things from the skin that achieved over 81% accuracy, identifying 8 different emotional states, and even 96% accuracy recognizing stress during real driving. So it's moving beyond theory.
That's incredible. So the goal for the Learning Companion's AI
Is to eventually tailor its responses, not just based on whether you made an error, but how you made it. Did the error come with a look of curiosity and interest, suggesting you're exploring in quadrant 2? Or was it accompanied by increasingly frustrated and angry mannerisms, signaling a slide into quadrant 3?
the emotional context of the error.
Exactly. Being able to reliably detect those subtle cues by computer and interpret them within the learning cycle. That's the huge research challenge. But it's seen as absolutely crucial for the learning companion to work as intended, providing that truly intelligent, empathetic, timely support.
Okay, so let's say the companion can sense how we're feeling with reasonable accuracy. How does it translate that knowledge into actual help? How does it support that learning to learn process?
It does it mainly through something called scaffolding.
Scaffolding, like builders use?
Kind of,
Yeah.
yeah. In education, it means providing temporary supports, fadeable supports, that let learners do things they couldn't quite manage on their own yet, like
Yeah.
training wheels on a bike.
Okay.
But Kort adds a twist. He says scaffolding shouldn't just fade away. It needs to be more dynamic. It needs to come and go as needed.
So not just disappearing, but appearing when needed to?
Exactly. Different moments call for different help. Sometimes a hint, sometimes maybe the answer to a small part of the problem, sometimes a review, and sometimes, crucially, no help at all, just letting the learner work independently.
So the AI's job is to figure out the right scaffold at the right time based on those emotional cues.
Precisely. It uses those effective signals to best tailor the scaffolding. If it senses that shift into quadrant 2 confusion, maybe a subtle hint is best. If it detects rising frustration, deep into quadrant 3, perhaps simplifying the task or offering a quick win on a subproblem is better.
Or suggesting a break.
Or suggesting a break, or changing the topic briefly to reset the emotional state. If it senses boredom, maybe it gently ups the challenge or introduces something new to spark curiosity again, push back towards quadrant 1.
So it's constantly adjusting the support level.
That's the idea. Dynamic, emotionally aware adjustments to keep the learner challenged, but not overwhelmed, always moving along that Excelsior spiral.
No, with all this sensing, reading emotions, maybe even physical responses, that big elephant in the room comes stomping back. Privacy.
Mm-hmm.
How on earth do you ensure privacy and confidentiality when a system is tapping into something so personal, so internal, it feels potentially invasive?
It's a massive concern. Kort calls it the issue of the 21st century, maybe as big as civil rights were before. And it's something the MIT Effective Computing Group treats with extreme seriousness.
How do they approach it?
Their policy hinges on transparency and user control.
Huh.
They're absolutely open with all subjects as to what the capabilities of the system are.
So no hidden sensors or secret monitoring?
None. Users know what's being collected, facial cues, skin response, clicks, whatever, and how it might be used. And they give users maximal control over the system, and crucially, complete control over any data gathered by the system.
Meaning I own my emotional data.
Essentially, yes.
Yep.
And all their work needs strict ethical approval from MIT's Committee on Using Human Subjects. It's like an independent ethics board.
That's reassuring.
It has to be, because it's vital that the learning companion isn't seen as irritating or annoying or creepy. Trust is paramount. And if the system isn't sure, if it can't confidently figure out the emotion or the right response,
What then?
then it should degrade softly with an acknowledgement of its limitations. Basically, it's better to do nothing or admit uncertainty, I'm not sure what you need right now, than to make a wrong or intrusive move. User experience and trust come first.
Okay, this whole system sensing emotions, dynamic scaffolding, ethical considerations, it's incredibly complex. How do you even test something like this? How do you refine it?
It requires really rigorous step-by-step testing. You start with prototypes, often simulated, and gradually make them more automatic. It's very iterative.
Simulated how?
Well, one key technique early on is the Wizard of Oz approach.
Wizard of Oz. Like, pay no attention to the man behind the curtain.
Exactly like that. The learner interacts with what looks like an automated learning companion. But secretly, a human researcher, the wizard, is in another room, watching the learner, inferring their state, and manually triggering the companion's responses.
Ah, so the AI isn't actually doing the sensing or deciding yet.
Not in the early stages. This lets researchers quickly test which kinds of interventions work best for different situations without needing a fully built AI. They can see how students react to different hints, encouragements, task changes, etc. It gives invaluable qualitative feedback.
Okay, so the wizard helps figure out what the AI should do. What's next?
Next, you start automating the detection part. You build AI components to try and spot those moments where intervention is needed.
And how do you know if the AI gets it right?
You bring in expert teachers, they watch video recordings of the automated system interacting with learners, they evaluate, did the AI intervene at the right time? Was the intervention appropriate? Was the hint helpful or confusing? Was the tone right?
So human experts validating the AI's judgment.
Exactly. This helps fine-tune the AI's emotion detection algorithms and its response strategies based on real teacher expertise.
And the final step.
The final stage is testing the whole fully automated system in realistic settings. You gather tons of data video, detailed logs of every click, every sensed emotional cue, every action the companion takes.
To see if it actually works.
To see if it works, identify its remaining weaknesses, and figure out how to improve it further. It's a continuous cycle.
It sounds like a long process. What kinds of problems do they expect to encounter even with all this testing?
Oh, they anticipate several common issues in this kind of complex human-AI interaction.
Such as?
Recognition errors. For one, these come in two flavors. False alarms,
Mm.
where the AI jumps in when it should, maybe mistaking deep thought for confusion.
Right, interrupting you. Annoying.
Very. And the opposite, undetected miscues, where it misses a clear sign of struggle, failing to intervene when needed.
Also bad.
Another big one is time lags. The learner pauses for a second to think, and the AI instantly offers help, breaking their concentration just before a potential breakthrough.
Ugh, that would drive me crazy.
Exactly. And then there's just basic interface confusion. The learner might not understand why the system did something or how to ask for help manually if they want it. It might feel unpredictable or patronizing.
So how do they deal with these inevitable glitches?
The core approach is constant refinement, and that principle of graceful degradation we mentioned. It must not be irritating. If the AI's confidence is low about the emotion or the right action, it's often better to do nothing or admit uncertainty. Keep the interaction positive, even if the tech isn't perfect yet.
Wow. Okay, what an incredible journey through Kort's work so far. From understanding the problems with traditional teaching through this wild calculus of emotions to the nitty-gritty of building and testing an AI learning companion. But Kort's vision seems to go even broader, beyond just the mechanics of recognizing emotions and scaffolding tasks. He talks about storycraft. How does something as ancient as storytelling fit into this high-tech vision?
It's actually central to his broader view of how deep learning happens. He brings in what he calls the bardic arts.
Bardic arts, like medieval poets.
Kind of. He makes the point that throughout most of human history, cultural knowledge was passed from one generation to the next by telling stories. That's how we learned, for millennia.
And classrooms are relatively new.
Very new, historically speaking. And he argues, sadly, we lost much of the power of story when we invented the classroom instruction model. Especially, he notes, in science and math, where story is almost totally absent.
Interesting, and storytelling is now seen as an emerging technology.
By the IE Computer Society, no less, which really highlights its value beyond just, bedtime stories.
So how does story connect to learning in Kort's view? He mentioned data, information, knowledge. What comes next?
Right. He says traditional teaching often stops at knowledge-integrated facts, the assembled puzzle. But what's missing is wisdom and story.
How do we get to wisdom?
He argues that to get from knowledge to wisdom, you have to fold in a value system. And in practical terms, that means addressing the dreads and desires of characters.
Dreads and desires.
As soon as you have characters with competing goals, fears, hopes of protagonist and antagonist, a challenge, you automatically create drama.
Ah, okay. The conflict drives it. And that connects to Tom Clancy.
Yes. Clancy's theorem, as Kort calls it, the vector sum of all fears. 0.
Meaning?
Meaning for a story to hang together, actions need to be driven by emotion. One character reacts emotionally to another's action, provoking another emotional response downstream. It creates this chain reaction fueled by fear, hope, desire.
So drama isn't just fluff. It's functional for learning.
That's the argument. It's not just education, it's edutainment. Drama helps engage, motivate, and make things memorable. Even in seemingly dry subjects, he suggests, finding the dramatic elements, spicing it up a tad, can fight off boredom.
How would this actually work in, say, a math class? Or with a learning companion?
Well, you could embody abstract concepts as characters. Imagine gravity and inertia as characters in a little story with their own dreads and desires related to solving a physics problem.
Personifying
Or
concepts.
telling the historical stories with the drama. Archimedes' Eureka moment wasn't just a fact, it was high drama. Galileo facing down the authorities, Newton and the apple myth, these are human
Wait,
stories.
not just equations.
Or modern examples like that show number threes using math drama to solve crimes. The idea is to embed this serious learning vitamins inside a compelling narrative, game, or quest.
And the learning companion could.
It could suggest relevant stories, maybe even generate simple dynamic narratives tailored to the learner's current struggle. Turn that recursion problem into a mini-quest where the learner is the hero needing to debug the looping spell. Make it engaging.
That sounds great, but realistically, how do you make that happen? Do scientists need to become screenwriters now? What about this STEAM idea, adding arts to STEM?
Yeah, it definitely requires collaboration. You need the technicians and artists working together.
Which isn't always easy.
No. But Kort points out the MIT Media Lab has done this for years, bringing computer scientists, psychologists, artists, writers, game designers together to build these kinds of experiences.
So it can be done.
It can. And other places are doing it too, like University of North Texas linking computer science and game programming. Even for smaller projects, Kort suggests trying things like improv theater exercises or his Dilbert and Sullivan idea mixing cartoons and entertainment. Just finding ways to build story skills and weave in the learning.
Okay, and then there's one more big concept. Multiple interlinked economies. That sounds abstract. How does economics connect to learning emotions?
He uses economy simply to mean the flow of a commodity. We all know the material economy, goods, services, money.
Sure.
But Kort identifies others. There's the information economy, bits, data, the attention economy, hiss, clicks, eyeballs, very relevant today.
Definitely.
Higher up, you get the entertainment and drama economies, stories, experiences. Then, critically for us, the emotions and learning economies may be measured in snits and wits, he jokes. And at the top, perhaps a spiritual economy, insights, connection.
Okay, so different kinds of flows, how are they linked?
Like a slinky, he says. A change in one ripples through the others. What happens in the attention economy affects the emotion economy, which impacts the learning economy, and maybe even ripples up or down to the material or spiritual.
So everything is connected to everything else.
That's the core systems thinking insight. To really understand emotions and learning, you have to consider the whole chain they're embedded in.
What does that mean for a learning companion?
It means its design, ideally, shouldn't just focus on the isolated learner. It should implicitly account for these other flows. How much attention does the learner have? What information are they accessing? Are they engaged by any narrative elements? It's about understanding the learner in their broader context.
It adds another layer of complexity. Are there any simpler, older ideas that still fit into this very modern framework?
Absolutely. Kort brings up the Socratic method.
Asking questions.
Exactly.
Yeah.
Socrates developed this incredibly powerful way to structure dialogue to facilitate learning not by telling, but by asking probing questions that help people think critically, see flaws in their reasoning, and discover insights for themselves.
Still relevant today.
Very much so.
Yeah.
Kort suggests you could even create templates for a Socratic dialogue, mapping out types of questions for different learning stages. He uses this himself sometimes to diagnose where someone's stuck.
Could an AI do that?
That's the potential. Instead of giving hints or answers, the learning companion could engage in Socratic questioning, guiding the learner through their confusion to figure things out themselves, building that true learning intelligence.
Okay, pulling this all together. What's the ultimate goal? Where does Kort see all this heading? How does this connect to, well, the future of civilization? That sounds grand.
It is pretty grand. He draws on Vico's historical cycles, divine, heroic, democratic ages. Kort suggests we're currently stuck in a chaotic age.
Feels about right sometimes.
Yeah, characterized by dysfunction, complexity, feeling overwhelmed. To get out of this, to move towards what he calls the cybernetic age, he says the path is clear.
Which is?
We have to seriously educate ourselves in the STEM disciplines, but not just facts and rules. We need a concentrated effort to master the fractious mathematics of recursive systems, the math needed to understand complex, interconnected problems.
So deeper STEM understanding is key.
Yes, but specifically through the lens of systems thinking. Peter Sinch's idea, seeing the connections, the feedback loops, the whole system, not just isolated parts.
Okay.
Once STEM truly incorporates systems thinking, then it needs to team up with artists. Add the A for arts. Get STEAM
Why the
to
artists?
shape this complex knowledge for public understanding, to weave it into stories, experiences, things people can connect with emotionally. This collaboration, this STEAM approach, is what can propel us into that more functional cybernetic age with a full head of scheme, as he puts it.
So it's the integration of deep technical understanding, systems thinking, and the arts, powered by technology like learning companions that can help us navigate the future.
That's the ultimate vision. Using this integrated understanding of emotion, learning, and technology, not just for individual education, but for societal progress.
Wow. What an absolutely incredible deep dive we've taken today. We've gone from seeing the flaws in how we usually teach emotion, all the way through this fascinating calculus of emotions and learning, and into the really transformative possibilities of AI learning companions.
It's really a paradigm shift, isn't it? Seeing learning not as just calmly absorbing facts, but as this dynamic, in, inherently emotional roller coaster
Yeah.
with cycles of progress, confusion, frustration, and recovery, where those negative emotions aren't failures, but actually vital signals for growth.
Yeah.
And the AI Learning Companion, it's not about being a know-it-all tutor. It's about being that guide on the side, helping you navigate your own emotional journey, providing the right support at the right time, and ultimately helping you get better at the fundamental art of learning itself.
So, the final thought for you, our listener, is this. What does it truly mean for your future and the future of how we all learn when technology can begin to understand and respond to the very heartbeat of the learning process? When moments of frustration aren't dead ends, but scientifically understood opportunities for breakthrough. Imagine a world where every learner, young or old, has a companion that doesn't just feed them knowledge, but helps them understand how they learn best, how to persevere through challenges, making resilience just a natural part of the journey. How might that change what you feel capable of pursuing or how you approach the inevitable challenges in your own life, work, and learning?